Hello students, today we are going to see about Cauchy integral formula for higher derivatives. In my previous videos, we have learnt about Cauchy integral formula and we did problems using this formula. F of z naught is equal to 1 by 2 pi I integral over c f of z by z minus z naught dz, where dz naught is a point which is lying inside the curve C given. Okay, so we did problems. Today in this video we are going to learn how to evaluate an integral having higher derivatives, higher order of terms in the denominator, and the general formula for those integrals is f n of z naught is equal to n factorial by 2 pi I integral over c f of z dz by z minus z naught the whole power n plus 1. This fn of z, we have f of z, the function in terms of z, and this is the first derivative of f of z, and we are differentiating the function with respect to z. If we have the symbol f double dash of z, it means we are differentiating f of z twice with respect to z. Like that we can extend, and we have the general derivative as fn of z. That means we are differentiating f of z n times with respect to z. So the general formula is f nth derivative of z naught is equal to n factorial by 2 pi I integral over c f of z dz by z minus z naught the whole power n plus 1. Here also z naught has to lie inside the curve given c. If it lies outside, the total integration will become 0. If it lies inside only, we have to use this Cauchy integral formula. Let me explain this using some examples. This is the first example what we have. We are going to evaluate the integral over c e power z by z power n dz, where c is the circle, modulus of z equal to 1. Already you know that. What is the general formula of a circle? Modulus of z minus a equal to r. That means a is the center, and r is the radius. Am I right? Here center is 0, and radius is 1. So radius is 1. So let me draw the circle. So with center 0, 0, 0 means the point 0, 0. With center 0, 0 and with unit 1, we have to draw a circle. Okay, this is the circle, and in this circle we are going to evaluate an integration of this kind. In my previous video, we have learned if we have in the denominator we have a linear factor, just z means easily we can calculate this using Cauchy integral formula. Or if we have quadratic form also, for example z squared minus z plus 1, like that if we have, or z minus 1 into z minus 2, also we can do it using partial fraction. First we have to split this into two fractions, and we have to do. For higher orders we are not able to proceed using that. For that only we have a general formula, f nth derivative of z naught is equal to n factorial by 2 pi I integral over c f of z by z minus z naught the whole power n plus 1 dz. Here also z naught should be a point which lies inside the curve c. Okay, here in the denominator what we have is z power n. Z power n can be rewritten as z minus 0 the whole power n. So now the point z naught is 0. Am I right? So first we have to make sure this z naught lies inside the curve or not. What is our z naught here? z0 is equal to 0, and 0 is the center of the curve given. So this z0 lies inside our circle C. So we can use this formula. F nth derivative of z0 is equal to n factorial by 2 pi I into integral over C f of z by z minus z0 dz, right? So here in the problem I can write this here, integral over C e power z by z power n dz, right? As per the formula given here, if we have a term n factorial by 2 pi I, not n factorial, here it is z power n, no, it should be 1 lesser than that, not n factorial. If I have n minus 1 factorial by 2 pi I integral over C e power z by z power n dz means the formula, using the above formula, we can write this as f. What number will come here, pa? The value should be 1 lesser than here, right? These two are same, and this is 1 plus 2, these two terms. N means here n plus 1, okay? So here n means here n minus 1, as well as here also n minus 1. So f n minus 1 of z0. Is it clear? We are comparing the formula, and according to the problem given, what we have no, according to that we have to rewrite that, okay? So we have z power n. So if it is n plus 1 means here n and here n. If it is n means here n minus 1 and here n minus 1. So here n only we have, so it is n minus 1 factorial and f n minus 1 of z0. But this term is not there in the given problem. So we have to take this to the other side. When it comes to the other side, we have to write that as 2 pi I by n minus 1 factorial into this will come f n minus 1 of z0. So this is the term which we are going to calculate for the given problem. Is it clear? So I have written the terms integral over C e power z by z power n dz, and the formula what we have is 2 pi I into n minus 1 factorial f n minus 1th derivative of z0. First we have to write what is f of z. Here f of z is the term, f of z is equal to e power z. We have to differentiate this up to n minus 1th derivative, right? So what is f dash of z? We are differentiating this once, so it is e power z. Can you tell me what is the formula for differentiating e power ax? d by dx of e power ax. When we differentiate this, what we are getting is e power ax into a, which is equal to a into e power ax. Tell me the formula for differentiating e power x, which is equal to e power x. What is the second derivative? D squared e power x by dx squared. It is also e power x. E power x, when we differentiate, we will get only e power x. How many times we differentiate? No, that much of times only e power x will come. Okay. So similarly, this e power z, when we differentiate this e power z with respect to z, we will get only e power z. So up to the nth derivative, when I extend, not nth derivative, it is n minus 1th derivative. When I extend, it is e power z only. What is z0 given? Z0 is equal to 0. This term only we are rewriting, no, z minus 0 the whole power n. So z0 is equal to 0. Already we confirmed this z0 lies inside the circle. So now we are going to apply in the formula. So what formula we have? This is the term what we have to calculate. So in this derivative, we have to take z0 as 0. Therefore, fn minus 1 of z0, which is equal to fn minus 1 of 0 equal to e power 0. Anything power 0, it is 1. So this term we got as 1. So what is the answer? 2 pi I into 1 by n minus 1 factorial. So what is the final answer we have? Integral over c e power z by z power n dz is equal to 2 pi I by n minus 1 factorial into 1. So final answer is 2 pi I by n minus 1 factorial. Is it clear? Let me do another example. This is the next problem. Here the second problem given is integral over c sine squared z by z minus pi by 6 the whole power 3 dz, where c is the circle modulus of z equal to 1. Modulus of z equal to 1 means it is a circle with center 0, 0 and radius 1. The same circle what we had in the previous problem. Okay. And here the point given is pi by 6. Pi by 6 is nothing but 3.14 by 6. Strictly this number is lesser than 1. This is a number which is lesser than 1. So this is a point lies inside C. Inside C. So after this confirmation only, we have to use the formula. Am I right? If it lies outside C, what will happen? The total integration will become 0. So this integration only we are going to evaluate, right? If it lies outside means no need to go for the formula, just to take that value as 0. But here this point is lying inside C, so we have to use the formula, right? What is the formula we have for higher orders, right? What is the formula? Can you tell me the formula? This is the formula we have. F nth derivative of z0 is equal to n factorial by 2 pi I integral over c f of z by z minus z0 power n plus 1 dz, right? Here, what is f of z? This term is my f of z. So f of z is equal to sine squared z, right? And z0 is equal to pi by 6, and we already found that this lies inside C. Okay, so this lies inside our circle C. And using this formula, we don't have this term with the integration. So we have to take this to the other side. So the given problem what we have now, it is integral over C sine squared z by z minus pi by 6 the whole power 3 is equal to 2 pi I. What is the power we have here? It is power 3. Power 3 means this, what will come in the denominator? If it is n plus 1 means n factorial nth derivative. If it is power 3 means what will come, girls? It is 2 factorial. Am I right? Am I right? Yeah, it is 2 factorial. So 2 factorial and f2 of z0. f2 means it is f double dash of z0. We have to differentiate twice. Okay. So using this formula for this problem, what we got is integral over c sine squared of z by z minus pi by 6 the whole power 3 is equal to 2 pi I by 2 factorial f second derivative of z0. So what we have to find now? F double dash of z0. That means we have to calculate what is f of z0 given. Sorry, not f of z0. What is f of z given? F of z is equal to sine squared z. We have to differentiate this term twice. Then we have to substitute z0 as pi by 6. Am I right? So let me do this. How to differentiate the sine squared, girls? First you tell me what is the derivative of x power n. N into x power n minus 1. Am I right? What is the second derivative of x power n? Already we have differentiated. Again we have to differentiate. N into n minus 1 x power n minus 2. Like that we have to extend. What is the derivative of sin x? It is cos x, right? Alright. Here we had to differentiate this sin squared once. How we differentiate this? Now you tell me the formula for x squared. 2 into x power 1. Am I right? So like that, in the place of x we have sin z, that is sin z the whole squared. We have sin squared z can be rewritten as sin z the whole squared. So when we differentiate this, we get 2 into sin z power 2 minus 1 into this sin z has to be differentiated, which is cos z. I repeat, when we differentiate sin squared z, it is 2 sin z the whole power 2 minus 1 into this sin z has to be differentiated, that is cos z, that is 2 sin z into cos z. Am I right? So which can be written as sin 2z. What is the formula for sin 2 theta? 2 sin theta cos theta. Am I right? Using that, I have simplified this term as sin 2z. Now we are going to find the second derivative of z. This can be directly differentiated. So cos 2z and this 2z has to be differentiated and we have to take this as a product. This is called chain rule. Okay. So which is equal to finally 2 cos 2z. This is my second derivative of f of z. In this we have to substitute our given z naught. What is z naught given? Pi by 6. Am I right? In this we have to substitute pi by 6. So f double dash of z naught is equal to f double dash of pi by 6 is equal to 2 into cos 2 into pi by 6, which is equal to 2 into cos pi by 3. So what is the value of cos pi by 3? What is the value of cos pi by 3? It is 1 by 2. So 2 into 1 by 2, 2 will get cancelled. So it is 2. So we got the answer for f double dash of z naught. F double dash of z naught is equal to 2. This we are going to substitute in the formula what we have previously. What we have integral over c sin squared of z by z minus pi by 6 the whole power 3 is equal to 2 pi I by 2 factorial into f double dash of z naught. This only now we got as 2. Am I right? This 2 and this 2 we can cancel. And f double dash of pi by 6 we got as, oh, we can have cancelled this. No, it is not 2, it is 1. Okay. So 2 will get cancelled and f double dash of pi by 6 is equal to 1. That we have to substitute. Already we have cancelled this one. So which is equal to pi I into 1. So the answer for this problem is pi into I. Is it clear? Now the next problem, we are going to evaluate integral over c z cube by dz by 2z plus I the whole power 3, where c is a unit circle. Unit circle means nothing but modulus of z equal to 1. The same circle what we had previously. It is a circle with center 0, 0 and radius 1. 1 unit in all the sides. Okay. So the same circle is given. But here in the denominator we have a term like this. But we are not supposed to have a term like this, that is of the form z minus z naught. The coefficient of z here should be 1, not 2 or any other factor. So we have to change that, and after that we have to do. So what we are going to do is, the given problem is integral over c z cube dz by 2z plus I the whole power 3. This 2 should not be there, so I'm taking 2 outside. So integral over c z cube dz by, I'm taking 2 outside. What is the power we have? Power 3. When I took outside, we have to take with the power. So 2 power 3 I'm taking as the common term outside. Though this will become z plus, here we don't have 3. When we, we don't have 2. When we take that outside, it will become I by 2. So I by 2 the whole power 3. So which is 2 power 3 is 8. That I can take outside the integration. So 1 by 8 integral over c z cube dz by, this one I can rewrite as z minus of minus I by 2 the whole power 3. Isn't it? Now what is z naught? What is z naught? It is minus I by 2. So what is the point we have? 0 comma minus 1 by 2. 0 comma minus 1 by 2 means this is a point lying here, which lies inside the circle. Am I right? So this is a point lying inside the circle. So our z naught given here, no, that is a point lying inside C. Okay, so now we are going to apply the formula for this. We don't have factorial n and 2 pi I in this side. Okay, so what is the formula we have? So this is the formula. Fn of z naught, nth derivative of z naught is equal to n factorial by 2 pi I integral over c f of z by z minus z naught power n plus 1 dz. Okay, here we have reduced up to this. I have taken this as equation number 1. Leaving this 1 by 8, I have taken this integration alone here. So integral over c z power 3 dz by z minus of 1 by 2 the whole power 3 is equal to, using the above formula, it is 2 pi I. Since it is power 3, 2 factorial will come and the second derivative we have to calculate. Okay, so after getting this, I will substitute the answer what we are getting here with the here equation number 1. So 1 by 8 has to be multiplied. Am I right? So let me calculate this separately. For that, first we have to write what is f of z and we have to differentiate that twice. Am I right? So f of z given is, what is f of z? F of z is equal to z power, what is f of z? Z power 3. Am I right? So this has to be differentiated 2 times. How many times we have to differentiate? Twice. So z power 3. When I find the first derivative, f dash, it is 3z square, and f double dash 3 into 2, 6z. Okay, so this is my second derivative. In that I have to replace z by z naught. What is my z naught? Minus I by 2. So f double dash of minus I by 2. Which is equal to 6 into minus I by 2. So it is minus 3i. This minus 3i has to be substituted in this place. So which is equal to 2 pi I by 2 factorial is 2. The 2 terms will get cancelled into minus 3i. Am I right? So minus 3i, which is equal to minus 3 pi I squared. What is the value of I squared? I squared is minus 1. So which is minus 3 pi into minus 1. Minus into minus plus. So it is 3 pi. So here the answer what we are getting is 3 pi. This has to be substituted in equation number 1. In equation number 1, we have to substitute. So 1 by 8 into this integration only we got as what is the answer we got? 3 pi. So into 3 pi. So final answer for this integration is 3 pi by 8. Is it clear? The next problem is we are going to evaluate the integral over c sine 2z dz by z minus pi I by 4 the whole power 4, where c is mod z equal to 1. Okay. So what is the z not given, pa? What is z not given? So z naught is equal to, what is z naught? Pi I by 4. So the point here is 0 comma pi by 4. Am I right? So what is pi by 4? 3.14 by 4, which is lesser than 1. Here the circle is with center 0 comma 0 and radius 1. Since it is lesser than 1, this point lies inside C. So inside C means we have to use the formula. So using the formula, this side we don't have that factorial term and 2 pi I. So that will come to the other side. Okay. So this is the formula, integral over c sine 2z dz by z minus pi I by 4 the whole power 4 is equal to, if it is 4 means 1 lesser than this 3 factorial and 1 lesser than this the third derivative. Right. So we have to find the derivatives one by one. Let me write what is f of z. F of z is equal to sine 2z. What is f dash of z? We have to differentiate this once. When we differentiate sine z, it is cos 2z, and this 2z has to be differentiated. So into 2. So it is 2 cos 2z. The second derivative, f double dash of z means already we have a constant 2. Cos z, when we differentiate, it is minus sine 2z into this 2 z has to be differentiated. So again we will get 1 2. So it is finally minus 4 sine 2z. Now come to the third derivative, f triple dash of z. In the second derivative, what we got is minus 4 sine 2z, right? So when we differentiate this, already we have a constant minus 4. Sine 2z, when we differentiate, it is sine 2z, when we differentiate, it is cos 2z into 2. So finally it is minus 8 cos 2z. Am I right? So the third derivative what we got is minus 2 cos 2z. And what is our z naught given? Z naught is equal to, what is z naught given? Z naught is pi I by 4. Pi I by 4. So z naught is equal to pi I by 4. We have to find what is f triple dash of z naught. Minus 8 cos pi I by 4. Cos 2 into, I'm sorry, cos 2 into pi I by 4. So this and this will get cancelled. So it is minus 8 cos pi I by 2. So minus 8 cos pi I by 2. What is cos I theta? It is cos h theta. Sin I theta is equal to I sin h theta, and cos I theta is equal to cos h theta. So this can be written as minus 8 cos h pi by 2. Right? So this we have to substitute here. This one alone we got as minus 8 cos h pi by 2. So the final answer is, 2 pi I by 3 factorial into minus 8 cos h pi by 2. 3 factorial is 6 and we can cancel this. So final answer what we are getting is minus 8 by 3 pi I cos h pi by 2. Clear? Moving on to the next problem, we are going to evaluate the integral over c e power z by z plus 2 into z plus 1 the whole square dz, where c is mod z equal to 3. If we have this, these terms are as a product, right? So that we have to first split into fractions using partial fraction. And then we have to apply the formula. So I'm taking only this alone. We have to use partial fractions. Okay, how many factors we have in the denominator? 3. So we have to take 3 constants, namely a, b, c. So a by first factor, this is a linear factor. Power 1 irka, so it is a linear factor. So a by z plus 2, power 1. Plus, inga power 2 irka, so first b by first 1 power we have to take. Then another constant c by idoda second power. So z plus 1 the whole square. So first factor a by first factor. Idhila 2 factors we have. So b by z plus 1 then c by z plus 2 the whole square. Okay. Now taking the LCM on the right side, what we are getting is a by z plus 1 we have z plus 1 z plus 2 we have z plus 1 the whole square we don't have. So we have to take the higher power for this. What we have, the LCM is z plus 2 into z plus 1 the whole square. Am I right? So a into z plus 1 the whole square plus here z plus 1 we have, but it is of power 2. So b into, and this term also we have to take z plus 2 into z plus 1 plus c into z plus 2. So after taking LCM, a into this term, then b into z plus 2 into z plus 1 and c into z plus 2. Let's say the same term. After cancelling the denominators, what we are getting is a into z plus 1 the whole square plus b into z plus 2 z plus 1 plus c into z plus 2. How to find a, b and c? We have to substitute values for z. We can substitute. We have to take this as 0 means z plus 1 equal to 0 means z equal to minus 1. One value for z we can take this one. When we take this as 0, z plus 2 equal to 0 means z equal to minus 2. So one value we can take as z equal to 2. Right. So first let me take z as minus 1. Substituting that on both sides, 1 equal to, this term will become 0 and this term also will become 0 since both the terms are having z plus 1 as a factor. So here alone we have to substitute. So c into minus 1 plus 2. So 1 is equal to c into 1. So c is equal to 1. We got one constant. Okay. Next, what is the value we have to take again? Z equal to minus 2. Z equal to minus 2 means in this expression only we have to take z equal to minus 2 means this term will become 0 and this term will become 0. Here alone we have to substitute. So 1 is equal to a into z plus 1 the whole square. So minus 2 plus 1 the whole square. So 1 is equal to a into minus 1 the whole square. So a equal to 1. Minus 1 the whole square is plus 1. So a equal to 1. So we got two answers. One is c equal to 1 and a equal to 1. For getting b, if we substitute both the z values, this term is becoming 0. So we are not applying that method here. Let me take the equation again. 1 is equal to a into z plus 1 the whole square plus b into z plus 2 z plus 1 plus c into z plus 2. So now for finding the other constant, we got two constants A and C, right? C also 1. For the other constant, we can substitute we are not able to substitute A as minus Z as minus 1 and Z as minus 2. Okay, so now I am going to take Z as 0. So 1 is equal to A into 0 plus 1 the whole square, that is 1 square. Then B into 0 plus 2, that is 2, into 0 plus 1, that is 1, plus C into 0 plus 2, that is 2. So 1 is equal to A value already we got as 1, B value only we don't know, so 2B, plus C value also we got as 1, so it is 2. So 2B plus 3, which implies 2B is equal to 1 minus 3. So 2B equal to minus 2, B equal to minus 1. So we got all the three values, right? Now we can split the given term 1 by Z plus 2 into Z plus 1 the whole square. A by, what is A? A is 1, B is minus 1 and C is 1. So 1 by Z plus 2, B is minus 1, so minus 1 by Z plus 1 and C is 1 by Z plus 1 the whole square. We have split it, right? Now come to the problem given. What is the problem given? Integral over C e power Z by this term into dz. So e power Z dz by Z plus 2 Z plus 1 the whole square, which can be written as integral over C e power Z dz by Z plus 2 minus integral over C e power Z dz by Z plus 1 plus integral over C e power Z dz by Z plus 1 the whole square. Let me take this as equation number 1. We have to find all the terms separately. So first I am going to evaluate the first term e power Z dz by Z plus 2. This can be written as integral over C e power Z dz by Z minus of minus 2. What is the curve given? Mod Z equal to 3. So mod Z equal to 3 means with center 0, 0 with 3 units we have to draw a circle, right? This is my circle. This is my circle, right? And here the point Z0 is minus 2. We have only 2 Z0. Here the Z0 value as minus 2 and this point Z0 as minus 1. And minus 2 means point minus 2 comma 0. Here it is minus 1 comma 0. This is minus 2 comma 0 and this is minus 1 comma 0. Both are lying inside the circle. So we can apply Cauchy integral formula. This is not of power more than 1. So first, in the first video what we have seen, no, using that formula we have to evaluate this integral. What is the formula, Pa? So it is 2 pi I into f of Z0. So 2 pi I, what is Z0? Minus 2. So Z0 is equal to minus 2 and my f of Z is equal to e power Z. So in Z we have to substitute minus 2. So f of Z0 is equal to e power minus 2. Am I right? So e power minus 2. So for this we have calculated 2 pi I into e power minus 2. Come to the next one. Integral over C e power Z dz by Z plus 1. Z plus 1, which is equal to integral over C e power Z dz by Z minus of minus 1. Already we know that this minus 1 is also a point lying inside our curve C. Okay. So using Cauchy integral formula, this integration is equal to 2 pi I into f of Z0. What is f of z? E power z. Here z naught is equal to minus 1. Therefore, f of z naught is equal to e power minus 1. So, which is equal to 2 pi I into e power minus 1. This is my second integration. Now come to the third one. Third one, what we have is integral over c e power z dz by z plus 1 the whole square. This is of higher order. If we have the whole square means, what's the formula? We have 2 pi I by, if it is n means n minus 1 factorial will come. It is power 2 means 2 minus 1 factorial. So 1 factorial. And here the first derivative. F down of, what is the point here? Is it not? It is minus 1. So this is the formula, right? So we have to find here for this f of z equal to e power z. What is f dash of z? When we differentiate f of e power z, we'll have e power z again. In this we have to substitute z naught. That is f dash of minus 1, which is equal to e power minus 1. So which is 1 factorial is 1. So 2 pi I into e power minus 1. So all the three answers we have to substitute in equation number 1. Therefore, integral over c e power z dz by z plus 2 z plus 1 the whole square is equal to, what is the first evaluation we got? 2 pi I into e power minus 2. So 2 pi I into e power minus 2. Then minus sign will come. Minus, what is the second integration we got? 2 pi I into e power minus 1. What is the third one we got? And it is of plus sign. So plus 2 pi I into e power minus 1. All the terms are having 2 pi I is common. So 2 pi I into e power minus 2 minus e power minus 1 plus e power minus 1. This term and this term will get cancelled because it is minus sign and plus sign. So finally it is 2 pi I into e power minus 2. So this is the answer for this integration. We have evaluated integral over c e power z dz by z plus 2 z plus 1 the whole square as 2 pi I into e power minus 2. Is it clear?